Hello. Huge audience. I love it. It's great. So just making sure everyone's in the right room. We're going to be talking about Azure functions today. So a little bit about using them for Glue and open source. I'm going to jump straight into it so we can talk to it as we go. I'm going to hope that this works. Nope. Maybe this is actually not. Cool. All right. So what we're actually covering, a few different things. So really, hopefully, being a 400 session, everyone's had a bit of an idea about what Azure functions are all about. Does a show of hands who's actually used functions? Okay, so cool. All right, so there is a little bit of an introductory to this as well, which is good. So Chris will go through a little bit of that as well, just to show you how to get started. But then we do go into a little bit more of a deep dive into some of the cool things that you can actually do with the functions. One of the big things that we're doing is looking at event-driven automation. So our company is all about that. Us as people are all about automation. So what we're trying to do is look at self-healing infrastructure and linking that all in as well with ChatOps. So does everyone know what ChatOps is? A show of hands who've done ChatOps? Yeah, cool. All right, so basically we use a lot of Slack. I know a lot of people use a lot of different tools that are out there. But Slack is one of the ones that we use in our organization. We see in a lot of our client sites as well. We'll be integrating to that. And this is also around the open source stream too. And so we're looking about how we're going to glue a lot of these open source different sort of solutions together using Azure functions. So we're looking at Nginx, not Nginx, it's pronounced Nginx. Chef Inspec, and I'll go into a little bit of detail about what that is later on, and bringing that back to Slack. One that's not mentioned there, we've decided to add a little bit sort of later in the piece, is Terraform. So if anyone knows anything about HashiCorp, so it'll be a discussion around how we actually use that to spin up these environments and manage them. Okay, pushing this button, pointing that way will tend to work, I think. Let's see. No, go next. Next thing. All right. So the way that we actually bring it together, so Inspec, and again, we'll go into a little bit more detail about it, but it basically is a product that's there, open source by Chef, and there's also a proprietary product there as well. But what it actually does is it looks at the different servers for compliance. So what we'll be doing is taking the logs out of Inspec that come out of that compliance, using some Azure functions to basically analyze those and say, are things good or not? Pumping that back into Slack so as that we can see that there's an issue, and then taking that from Slack and being able to control, again, from a bit of a Slack command, is to be able to actually push through and say, I'd like to do this on the back of that event that just occurred. And that's kind of the glue that we're putting together. All right. Next slide. Thanks, mate. So who are we? So Vibrato, and it's Vibrato with one R. So Vibrato is a company that's all about automation. So we've been around for about, 2 or 3 years now. But ultimately, it's DevOps and everything that really goes with it. So DevOps is definitely a cultural thing about bringing developers and operational people together to lower the number of handoffs. But we're also about all the tools and automation that goes along with that practice to make it better. So we do a lot of Azure, AWS, GCE, all the different clouds, but also with the open source champion. So having done this ourselves and most of the engineers for over 10 years, or even more than that, we work with a lot of the companies. So we're the #1 actual Chef partner here in Australia and the #1 HashiCorp partner in Asia Pacific. So if you want to talk about any of that later on, please come and see us. All right. So that's me. How big is that picture? I love it. I love it. So I look better in person, right? Anyway, awful photo. I've copped so much crap about that online, so it's all good. So I'm actually the CEO of Vibrato, so it's apparently still technical. Now, most of my staff will talk to you and say, no, he's post-technical Pete. That's great. I'll take it, whatever. But yeah, I love to, even as the CEO of the company, I like to keep my hands dirty. I want to know everything that's going on. So we helped to put this presentation together as well today. So also director of Hava. So Hava, you see a little bit of an insight to Hava a little bit later on in the presentation. But Hava is a tool that's used for visualization of cloud environments. So it automatically generates diagrams and architectures of what you're running. The reason I mention it and why it's up there is that in the next 2 or 3 weeks, it'll have Azure support. So be able to, instead of the typical viz thing that you see, which I don't know, it's cool, you get some real diagrams that look good. We obviously have Chris as well. Even better picture. Like, I don't know which club that was in. But anyway, but basically, Chris is one of our senior automation engineers. He's an absolute expert, everything technical, and one of the best architects that we have in the company. Chris is basically, I just realized that the elite board game is there, so sorry, I didn't want to delete it. It's not true, and I was meant to delete it, so I apologize.
That's him.
I'm the elite board gamer. But really, Chris did actually put the presentation in terms of the technical stuff behind the scenes. He's the one who's been actually gluing that all together. So if anyone wants to ask questions after that, please berate him with questions. He'll love it. Cool. He's got to stop pointing at the screen. Okay. So what are Azure Functions? Now, I knew there was a few people that didn't put hands up in terms of what they were talking about and what Azure Functions are, but Azure Functions are actually functions as a service. Now, really, it's about just-in-time code for us, right? So it's pay-per-use. So a lot of people ask why do we use functions? What about containers? What about real servers and that sort of stuff? One of the big things is just in time. I want to run this small snippet or piece or function of code. You pay for each time that you run that, and it's very tiny, and you don't have to manage any of the underlying infrastructure. So that's also a really cool thing that's been leading to functions and serverless in general coming to fruition. And it has built-in integration for a lot of the other services that are there as well in Azure. So whether or not you're connecting from blob storage to any kind of event, it really does provide you that glue, which is what we go to talk about. Exactly that, glue. So what do we use it for? So a lot of people use it for just responding to API requests. You can really use it in that serverless sort of framework. But we actually use it quite heavily for just-in-time code. And it really is our operational glue. So what do I mean by that? I hate writing scripts and then writing more scripts and then running them all the time. I hate cron jobs. The idea, especially in a Linux space, of having a cron job that runs every hour and it picks up whatever it found over that that last hour. It's just stupid, right? And it's also a lot of manual stuff that keeps happening. So what we use it to do is we actually use Azure so that it's event-driven architectures. So is that when the event immediately occurs, we're able to glue it together to another service or another thing that we want to go and run. And the other part as well is, I think we talked to it a little bit later, it's just getting back some of our time. So I'll go into this. Do you want to click next? Next one. Cool. Right, and we're also going to talk a little bit about the development pattern. So when Chris does jump up with his tech, he will actually be showing you how we've got it. It's basically built in with Git as well. So that means that as you're actually developing these functions, doing a push to your repository, and it could be on a branch or into the master itself, that automatically updates the Azure function straight away, live in production or in whichever area that you're actually pointing to. So we'll be showing a quick demo of this, and I think that might be the first place that we start into. Cool. So over to Chris, and see if you can switch across to your screen if that works. And we're going to walk through exactly some of that stuff that we just said, which is getting started.
There we go.
And just talking through the delivery of some of those functions.
Okay, so first thing you might notice is this is an open source session, so we are running on full open source here. This is running Ubuntu. There's no Windows to be seen here.
You make it like it's a dirty word. What are you talking about?
Just a quick overview getting started. You want to kick off your first Azure function. The new button in the portal, compute, sitting down here, function app. Very quick and easy to get started. I'm going to click out of this one and jump into one that I prepared earlier that has just spun up, and I kicked that off about a minute and a half ago. So that's already provisioned all the back-end infrastructure that is needed to run our functions for us, run our code just in time. Jumping in and getting started, you've got a bunch of scenarios that you can choose here, or you can jump in and there's a bunch of ready-to-go templates, different languages. Choose the language that you speak. You don't have to worry about learning a new programming language. If you're just an ops guy who knows PowerShell, you can start hooking in webhooks and things into your PowerShell. It's really powerful to just really get started very quickly. So let's, even bash guys. There we go. So yeah, if you wanted a webhook for your PowerShell, it's as simple as that. You can start writing your PowerShell and responding to webhooks. You've got the all the Azure PowerShell commandlets available to you, so you can jump in, and then right here you've got a webhook that you can hit from wherever you want to run your PowerShell. Once you get a bit more in depth, doesn't matter what editor you use or what OS you're on or anything, you can interact completely through Git. So running VS Code on Ubuntu and writing C#. So if I wanted to push this to my develop branch, it would be as simple as we need to.
And you notice we are running Visual Studio on something other than Windows now. Yep. I thought we'd earn some points in doing that. Yeah.
Save it. Commit it and push it. And Azure behind the scenes will run through and fire off webhooks from GitHub and roll your code out. So not only do you get your just-in-time code as a service, you've got your full CI/CD serverless. And setting that up from the portal is simple. Start from source control, set up, pick your flavor of source control. We're using GitHub. If you're not auth, it'll run you through their OAuth process. Go for the vibrato one and hook yourself up to a GitHub project. You can pick your branch, whatever. I'm not gonna, actually let's do that. There we go. So that'll hook up all the webhooks on GitHub side. And as soon as you commit into GitHub, your code's pushed straight through into, let's see how quick this is.
That was a pretty fast click-through.
There we go. It's already fetching from GitHub, and it's going to set up all those functions that we've got defined there in GitHub already.
Absolutely. It actually is that. I know it seems like a really fast clicking and making it seem easy. It is actually that easy. And getting started with a really quick, having a GitHub repository is quite fast as well. Who's actually got their own Git that they're running? Most people in the room do this. Okay, cool. Yeah. So being able to plug it in and plug it into a branch as well is literally, the first time I did it, it took about 5 or 10 minutes to get going, and I was actually in a good process of practicing continuous integration with the function straight off the bat. Even with Bash, right? It's like bang, straight into doing it properly.
Cool. What number are you on?
I'm on 5, man.
5?
Yeah, you're just pushing random buttons there. Okay, so
That's how I work.
okay, so the real question is, what can we achieve with Glue? So, hang on a second. Did you pull me forward? Yeah.
Where do you want to be?
Right there. Okay, so the biggest thing, like I said, is that what we want to do. So we start working with these functions, and that was just a very quick introduction to what how you can set up the Azure functions to get started. But because we keep talking about some of the Bash and the PowerShell and using some of those scripts, we really want to be talking about automating operations, right? So I guess the biggest reason why, and we always use this sort of analogy, is I don't want to be woken up at 2 o'clock in the morning, right? And if I am woken up at 2 o'clock in the morning to work on something, I'm going to be in a pretty groggy and pretty crappy state, and so I want to make sure that my options are reduced about the things that I should go and click and do. I basically don't want to delete the database, which apparently seems to be a pastime of mine. So we also want to be able to react quite quickly, and we want to be able to mitigate those issues. So the scenarios that we're also looking at as we run through the rest of the demonstrations are really talking about saying we want to have event-driven architecture. So we want to have something possibly bad or even good actually happen. We want that event to be passed into an Azure function that says, hey, I've seen this, I'm going to go do something with it. And then 2 things that we want to look at. So one way you can do after that, and we haven't done it for the purposes of this demonstration, is to basically say, go and do this thing straight away. And then the glue is complete. There's no manual, sort of interruptions at all from a human. But really as well, though, what we've done is we've made it so as that it's a little bit like I need to provide you with an option because this has happened, and it's more so a question, do you want to do A, B, or C, right? So just actually providing some narrowed kind of solution so as that we can mitigate the situation fast, but still have a level of manual intervention. Next one? Yeah, cool. So who does chat ops? And I think I asked about it before, and people are actually doing this properly with integrations. We'll jump straight into the next slide, Chris. So in that, we need to look at a place where, at least this is what we do at Vibrato, we want to look at a place where you have all of this information in one area. So we practice chat ops, and we practice having Slack channels, and you can do it with any of the sort of tools that you use out there. But really what we're trying to do is make sure we've got a really fast feedback loop. So we make sure that everyone in the team has access. So setting up things like Slack for everyone is very important, making sure they're all in the same spot. And then what we do is we integrate all the outputs from the different systems, or as many as we can. We connect it into that Slack channel. So what we're actually doing is trying to have a look at, hey, this event has occurred. Someone's either reading it and saying, hey, don't worry about that, or someone says, oh, wow, I didn't really notice that was happening. I would respond to it. So that's very manual. But at the same time, even though you might actually do the automation and do some of this, Azure functions and have it running as you glue, you also want to see what the bots are doing. So at the same time as well, you're looking at the channel and you want to say, cool, it automated it, but then you see a big flood and it's automated, all of a sudden it's done something like 30 times, you're like, why is that occurring? So it's probably doing an okay thing and support it, but you actually keep an eye of it, and you actually make sure that you've got some consolidated place for the operational coherence, whether it be automated or manual. So going to do a little bit of a a demonstration on this. Now what we're actually going to show, Chris will switch to it now if you want to.
I'll just check the channel and make sure nobody's...
No one's chatting there? Yeah, all good. So what we are actually switching to, funnily enough, so we talked about Harvard, and like I said, we're currently in the process of getting some of the stuff going there. So this is actually the live channel, so if anyone types anything in here, well, we're all in bad trouble, but no, I'm just kidding. Okay, so what's really important here is you can even see things like this, like Bugsnag, right? So when we talk about the event-driven architecture, we want to be able to have everything coming in here, and you can see straight away, so Adam's one of the engineers on the project, and you go through and he's like, hey, we've seen this bug, and he's like, nah, don't worry, that's me. Straight away. But again, if you don't have this sort of integration going, then what ends up happening is that could be a conversation that goes around for like a couple of days, even if it's longer than an hour. Also, someone sees it and goes, oh my goodness, I need to react to that, right? So all of a sudden you're there, 3 o'clock in the afternoon, and you see that event and someone's doing it, whereas if we actually pick up on it very quickly and the person sees that in the channel, like, hey, no one act on it, please, that's me doing it. So again, it's really important to have all of these things in there. So that was the Bugsnag, and then there's also the development channel if you want to switch to that. And there's a lot of work going on at the moment, funnily enough, around even the Azure development space that we're going. And so having some events to make sure that we're actually, again, gets a little bit dry, but yeah, obviously, again, and pop you up in there going, yeah, it's me, or okay, I've done all the things, and bloody IP config in Azure. Okay, so he's definitely fighting with it, but they'll get that going. But yeah, cool. Right, so switch back and I'll get to the next channel. So let's get into some of the different open source products that we said we're going to glue together and get into the fun stuff. So not Nginx, it's Nginx. Again, I used to actually say Nginx until my business partner told me I sound like an idiot. So it's Nginx, don't make a fool of yourself. So for those of you who don't know what Nginx is, right, it's basically a very simple web server, like IIS, only much simpler, actually just like the simplest thing, but it's actually very powerful. And it scales very well, and it's used quite often now in a lot of different solutions right across the world, and being that front-end web server that does proxying and stuff like that. It says there that we're going to be doing a quick demonstration with ARM. So we did that. That was boring. It was too easy. So we went to show you some more open source stuff, and so what we're actually going to demonstrate is the ability to do it with Terraform. Now, I mentioned this before as well, so if you want to look up HashiCorp stuff, HashiCorp has got a lot of products. Terraform is one of them. They also do console, vaults. There's a whole heap of things really for that DevOps tooling space, and it's really good stuff. So Terraform, the reason why we chose that as well is Terraform provides an agnostic language. Now, we don't normally promote like a kind of multi-cloud or sort of lowest common denominator, but what Terraform does give you in the fact that it is that same language is that as we're walking through it, it's the same notation, same language that you'd use whether you're doing it in Azure or AWS or on-prem or wherever it is. It just means that another engineer coming into it, regardless of their background, has got an understanding of how it hangs together. It also has a really cool way of managing state. So we'll run through this, and Chris is going to give you a demonstration on basically doing the Nginx spin up and what that Terraform framework looks like. Switchy button.
There we go. So this is HCL, which is HashiCorp's configuration language. It's basically bastardized JSON.
Yeah, whoa, language.
But it's a very simple way to sort of notate how you want your infrastructure to be configured. And yeah, as Pete was saying, the great thing about using something like Terraform is it doesn't matter which cloud you're working on, you get to speak the same language. And that's becoming more and more important as more and more cloud services enter the market. What we're scrolling through here is part of our entire template. So what Terraform also lets you do is divide your template up into separate files, and it will combine that all together and figure out what needs to run in what order, all your dependency mappings and everything like that, and provision everything as it needs to be provisioned based on what you've called where. And so for example, I've called a template provider here that's going to just generate a very simple index HTML template. Terraform will know that that means it needs to run through its templates before it runs through its server deployment. Things like that. So to actually provision Nginx on these instances, very simple, using OmniTruck from Chef. It's going to install the Chef client locally on the instances, install a couple of cookbooks from the supermarket.
Just on that as well. So who's heard of Chef? And yeah, who's actually used Chef before? Yep, cool. Okay. So Chef, just so you guys know, Chef especially in the Microsoft space is ridiculously powerful. One of the cool things there, just so we mentioned that supermarket, is that a lot of the like within their sort of notation language, a lot of their sort of recipes and cookbooks, some of the default ones that have been out there for a long time for just the standard things you would do to be able to spin up quickly, it's in a place which is all open source in their supermarket. So very quickly you can just go and grab the standard install for Nginx, for Acme, whatever it might be, and that's actually got a whole heap of stuff behind it where it does all the config management and spin up. So it's really good when you're building machines like this. It's really good for baking things as well. Chef is out there in the hall as well. So if you want to go and have a chat with them, we'll also be presenting on some of the real low-level stuff here with them again tomorrow. Sorry, mate. Go on.
No, go for it. I'm not going to try and stop you talking, Pete.
I wouldn't let you, man.
So what we're going to do then is use local mode on the Chef client. So Chef is often run as a client server where you'll have a server coordinating all your runs. There's also a feature. It used to be called Chef Zero, which was a standalone sort of client. It's now local mode built into the Chef client, and it's really great for doing things like quick proof of concepts, testing all your Chef deployments, and also very excellent for doing demos. So you don't need any infrastructure in the background. So Terraform's just going to call into the instance that we're spinning up and say, hey, execute this file here, which is just our Chef recipe that's saying add a repo to our apt repositories and install Nginx, install that's encrypted client, and put this file where it needs to go. It's very simple, but it's very extensible. So let's...
What we've got there, if you look at that variable, this is another part of Terraform. When you actually create an instance or a VM of a certain type, you can actually say that you want a certain number or count. So for part of the demonstration to show you to spin up, we thought the easiest way to do this is to show you that. What are we running at the moment? How many are there?
4. We're about to go to 5.
Yep, there you go. So we're at 4, we've set it to 5, and then this is a good way to show you how some of the different state changes in Terraform.
Yeah, so what we've got here is this count variable, and that's scattered across a whole bunch of resources that need to exist for each instance, and Terraform's just going to take care of how many we need to do that. We're also using a tool called TerraGrunt, which is just a wrapper for Terraform at the moment to do a bit of the state management. More open source stuff. I'm not going to dig into that one too much though. Google it if you're interested.
Or come and speak to us afterwards.
So Terraform's going to go through here and check all the stuff that it knows about, pull back its state from the Azure API, and did I hit save? So.
And the first part that Chris is running there is the plan. Yeah, this is not executing.
So this is going to go through and it's going to look at what's there. It's going to look at what you've defined in your Terraform file and go, hey, there's a new instance here. I need to do all this. So I need to spin up a new network interface. I need to adjust some of the config, and I'm going to spin up this new virtual machine. Now I know that at least one person in the audience has clued on that there is a plain text password there, but it is disabled, so don't even try.
Yeah, I was going to see all the phones come up at one go.
So
we always have a plain text password as features. Never do that.
Never do that. So we're going to hit this and hit apply, and it's going to go through and check all our state again, and then it will
Go and do stuff.
start spinning up our instance. So I'm going to move away from this, and we'll go back through what it's actually done a bit later on, because it's going to take a little while to spin up.
Okay, so that was showing a little bit about the Nginx. So if you had a very keen eye there, you would have seen in that actual Terraform repository we had there was also the inspec components and some of the other bits that we've got. So inspec, again, like I was saying, open source product. I don't know if any of you out there actually care about compliance, or your companies or the places you work care about compliance, kind of a thing that comes up. We sort of have automated a lot of the world now, and then we get to the back end of a lot of these projects, and even though we've gotten rid of things like security, so the DevSecOps and that sort of stuff, we end up with compliance that comes up afterwards, and that's writing of documents and someone coming back in and auditing, not so much the security even, but just looking through and saying, you've done that, I went and checked every one of your machines, now that's running, now that's it. It's like, it's really boring, and again, in line with automation, it's very tedious and manual. So Chef actually released the product called Inspec. That's the open source version. They have a proprietary version called Compliance. It has really, really cool, the visual tools and the actual reports that you want generated. Definitely go chat to them about it. It's a powerful tool, and it's out there in community growing a lot these days. But what we're doing with Inspec, and I should switch to the next page, is making sure that we actually check off the servers and say, are they compliant? So we have Nginx running, and what we'll also be showing is having a look at that Nginx, and there's probably a couple of things. What we were going to do was test out the ciphers, and so you can look at things like SSL and say, I don't want to be using that cipher. We do it. But what we chose actually instead was to say something probably a little bit more common, which is, I just don't want those ports to be open, right? So actually checking and saying, if port, I don't know, whatever it might be, 2 is open, that's not really good. We don't want anyone connecting to SSH, whatever it might be. So what we've actually done, I think, what are you protecting against? And you'll go through it anyway. Which port are you looking for?
443 should be open and 80 should not.
Right, cool. So again, from the compliance perspective, there'd be some level of compliance that we go through where you'd have your scripts that are written, and Chris will take you through some of this as well, that'll actually say, across all these boxes, if we start to see that for some reason 80's open and 443's not, someone's done something they shouldn't, or something's switched to a state that we didn't expect it to be in. So Inspec can actually be run in a periodic manner, so where it's just constantly running from the Inspec server and checking all the boxes out there. Doesn't need an agent, doesn't run anywhere. That requires that just will connect over SSH or whatever it might be when it's trying to actually look at the stuff that's running on the server. Or you can do it in an ad hoc fashion. So we're going to show you the ad hoc fashion because we're going to show you how we've glued it all together. But ultimately, the big thing about it is that it provides us with logs that come out as well. And logs are great because that gives us an opportunity to tie that back into some Azure functions, which are the way that we're actually going to glue those logs into the alerts that we want to see. So I'll switch into showing you now that. I might get this button for you, mate. So here we go.
Oh, cheers. Thanks.
Nice.
I wasn't quite ready.
There.
But there we go. Along the same lines as Chef, Inspec has a growing supermarket of checks already available for you. So we have here an Nginx one. That sounds like something that would be good to run against our Nginx server. So let's just see what happens.
Has anyone seen Inspec before? Anyone used it? Okay, cool.
Cool. So we're going to here run directly from the supermarket. Don't need to download or install anything. Run this Nginx baseline. Inspec's going to shell across to our SSH across to our instance and run that there. It's not going to install a client or anything. It's just going to run straight across the wire. Oh.
That was meant to happen.
Turns out you actually need to harden things rather than just installing them.
Do you want to go through some of that that's just there quickly?
Who would have thought? So what it's checked here is it's checked that the files are owned by the correct users. It's found that the config files are readable by the world, which is, well, not the full world, but anybody on the instance. It's also found that we've got the default sites enabled, and then it's got a bunch of different security configurations that are sort of not best practice. So standard default configurations that should be really turned off. There's also a bunch of hardening stuff that's not even looked at. So it's basically saying, yes, we've very much failed this inspect run. So what we're going to do...
We're not going to correct all those, just saying.
No. Not live, we're just going to run through them all.
Yeah, one by one. Wait, bear with us.
So we're going to write our own very small test, which is purely going to be checking port 80, making sure it should not be listening. And you get to use this very human-readable language to define all your compliance. You could basically hand this to a non-technical person and they'd be pretty much able to read through this document and say, yes, those are our compliance standards. Then you can take that and hand it off to Inspec and run it against your actual infrastructure. So it's great for having that documentation that is up to date because it's also your code. So we'll grab this one is out of compliance. There's a lot less info here. So here we go. So this is saying, yep, we're not listening on 443, we are listening on 80. So this server is out of compliance and should be alerted on. And what we can then do with that to start to bring that into the automation space is output that straight to JSON. Not your ops guy called Jason.
I hate that guy. I don't know a Jason in that space, that's fine. And just quickly so you can see there, remember we had the number of counts of the servers that were there? So what we're actually looking at there is that one of these servers has fallen out of compliance. And that's why we want to basically check that and say, that's not cool, I want to know if that happens.
So we've got a JSON file here, which is great, but it's not really going to do a great deal sitting on this server. So let's upload that to blob storage.
Jumping ahead to the next section, man. So, yeah, I can't believe you just did that.
There we go. All right.
Just so we'll bring back the slides just quickly. Okay, so what we actually just got to there was he cheated and went forward a little bit. We are actually at the fun part, which is we're going to be starting to walk through the functions that are created behind the scenes that will make this sort of work. So what we are looking at, really, and this is the sort of glue we've been talking about, is that inspect log, and that's what you would have just seen there, but you sort of just have to head to. So we've gone and run that command, and then we need to actually figure out a way for those logs to go somewhere and also be actionable. So the output that actually runs in that command goes and generates a new blob, right, in the storage. The reason why we do that is that it means that it can actually trigger an event. Now remember we were saying as well that Azure Functions are integrated already. There's a whole heap of built-in integrations with a lot of other things already in Azure. So what makes it really good is that one of those things being blob storage. So what we're actually doing is saying, hey, when the blob storage actually has an event triggered that says there's something new, cool, we go, okay, as soon as we see that, that's actually what we tie as the event to trigger the first function that runs. And that first function, clearly all it does is it says, hey, I know I should be going and checking that blob storage and reading it and looking for any errors. Again, all event-driven. So it will actually go and look at what was written and say, hey, that's bad or it's good. Now, if it's good, it's got to do nothing, and we don't have to check it. So they're straight away in that principle and actually using those functions. We've actually probably saved an engineer who knows how many hours jumping onto boxes and running them all themselves, right? So this is already jumped on. So all passes, it's fine. So a lot of those web servers that are actually running are all good. If it actually fails, that's where it comes to the next. So if it looks at it and says, hey, I actually found something bad, then that same function that we run, and we'll walk through this in a second, that same function will actually jump into your Slack channel and we'll publish this occurred, right? That's important again, so that might be triggered on someone's name, that could have something that's in there that someone has got their own preferences set up inside a Slack channel to say, if I see that sort of event in a channel, alert me. Again, a little bit more glue to actually plug into what they're doing. So that person, again, that's where you have that might trigger something in a queue or something that also has them wake up and say there's something in a Slack channel for you to read. Once they do that, the person reads the Slack channel and either looks at it and says, I don't care. Like, seriously, I don't care. One of those is not compliant. I'm actually going to do nothing. Probably not. They're probably going to look at it going, I probably want to make sure that I plug that gap, and so I'd like to do something with it. So that's where it moves into the next part, where what we actually have is a slash command in Slack, where we basically say, command do this, right? And so what it does is that itself picks up the either stop, change, destroy, disable, leave running, whatever that might be. It picks up that attribute. And then what that actually does when you type that command is it kicks off yet another Azure function. So that Azure function says, hey, cool, it's told me to go and do something. I've seen this event from a webhook, right, out of Slack itself. I'm going to go, and they've asked me to go and disable that system. And so if you think about that entire pipeline now, what we've got running, this is what we're going to walk you through. We have a system that's running that's constantly looking at the servers. Again, now it's no touch. Something's actually looking for compliance, constantly running. When it finds that thing, it then goes and says, hey, I've found a problem, and now I want to go and alert someone. And that goes into the Slack channel. So now we've glued that component to it. Now the whole alerting thing is once it's seen something, it's also been done. Then having the ability for someone not to even have to actually go and log into a console, not to run a script themselves, but anything, but straight in that Slack channel where they got that information, they're actually then going and acting on it, and behind the scenes, all the operational components that need to be taken care of are done for them. Then we've actually glued the whole piece together. And so that's the premise of what we're about to walk through now. Now you can switch back. Oh wait, okay, now you can.
All right.
And we're going to walk through some of these functions in a bit more detail now so that you can actually see how these pull together.
Okay, so...
Start from the beginning with that blob one, just so we know where that first event came through.
Yeah, so this is our blob trigger. And it's hooked into blob storage. So what's going to happen is file is going to arrive in a storage account, in a blob container, and that's automatically going to pass through the contents of that file straight through to Azure Functions, and we can start developing on top of that and doing what we need to do with it. This one's C#. I'm not going to claim to be a C# developer here.
Do you want to just walk through what's actually doing that?
And what we've got. So, thanks, Pete. So we're just going to run through. So we got that JSON output from inspect. So we're just going to deserialize that and turn that into an object. So that's taking the JSON, parsing it through, and turning it into some objects that C# can understand. Log a bit of data, and then it's just going to loop through all of those results and pull out all the ones that have been marked as failures. So that's going to pull out these here. So these results here are going to be pulled out of that JSON. And then if we've got any results that have failed, it's just going to loop through and pipe through a message through to Slack. And the way that ends up looking is we've got a bot that's chatting in our Azure channel, and that's going to let us know that these things are going wrong. You can kick that off again so you can see how quick it is.
And that inspect bot as well that was created.
Yep. So all this is done using inbound and outbound webhooks in Slack. So you don't need to worry about doing all the OAuth stuff. Writing Slack bots, there's a lot of tooling out there for it. It's not as hard as a lot of people would think, but in doing this sort of simple operational glue, you don't need to go to that level. You can just have inbound webhooks, which are simply posting through to a URL, and you can have your outbound / commands, which are calling a webhook somewhere else. You can auth that with pre-shared tokens that allow you to ensure that you aren't exposing everything to everyone. Security best practice on a few of these coding things leaves a bit to be desired. This is pretty rough and ready, but it's just to give you some ideas of what you can build. So what we've got is that message coming through to Slack. And then we decide that, yeah, that's probably not a good thing, so we probably want to lock down that instance. So we can just fire straight back from a / command in Slack. It's going to send through a message telling you what it's doing. It's going to send through a message to the channel, so that whole chat ops and that continuous flow of information back into the channel. It's going to let everybody know that I requested to shut down an instance. And it's going to go through and it's going to hit this other one here. So this is a function that's bound to a webhook. So that's going to get a request message from Slack, which is going to have a JSON body that we're going to parse for what we actually wanted to do, and then it's going to send back the confirmation, but it's going to do everything. One thing working with Slack webhooks that you need to be aware of is you need to respond within 200 milliseconds. So you need to get that first response back really quickly. So what it's going to do is not wait for everything. It's going to do all the rest of its operations asynchronously. So we're going to reply to Slack and say, yes, we've got this. Then we're going to send a shutdown request. So that's just another webhook that we're calling out to, which is...
So that's another function to itself, yeah?
Yeah, that's another function that we've got here, which is a PowerShell function.
And that's because of the millisecond response time, so we need to make sure that we respond very quickly.
Yes.
And then pump that into the next one, yeah?
Yeah. So, hard-coded variables. I didn't fix that one up. So what this is, so who's got a bunch of like PowerShell scripts that they're running all the time to just do stuff sitting on their desktop or...
Yeah.
Yeah.
You got that little folder there,
yep.
tools folder?
So...
Yeah. Okay. That's kind of what you want to move.
Yeah. So this lets you use that a little bit more dynamically. So this one's just going to run through, it's just going to call us a stop VM on the Azure PowerShell commandlets. And that's going to sort of take that instance out of service straight away. So if we take a look at our instance 3. That's been deprovisioned and stopped. And if we look at this now, we're now getting a page served by a different instance. So the load balancers realize that that instance is out of service, and it's no longer sending traffic through to that. One of the other things that you can hook into, which can give you a lot of really quick information on what's going on in your environment, is the Azure activity logs. So activity logs are your central location for everything that's happening in Azure. And we can pipe that through to event hubs, which can also then be hooked in back into functions.
You're probably getting the idea of the glue to the, yeah. We basically don't want to have to do anything. We're trying to automate ourselves out of a job, and that's how we're doing it. And just quickly on that, just play through that story, you would have seen it. So when we switch to the other web server, if you play through that same idea of there are 4 web servers running, you're in the middle of the night, and you have woken up at 2 o'clock in the morning, and now you have looked at it and gone, I know that that's not going to take the entire thing down. So any of those that are, non-compliant, I'm going to switch them. I'm just going to run this right now, run that command, and go back to bed. Because the cool thing is that you can mitigate it. It's that part about that having that very quick feedback loop. So you can mitigate it pretty quickly and be able to go back to saying, I'll tackle it tomorrow safely, right? So you know that you're not actually leaving your environment in a bad state.
So we can hook into same sort of system with the Event Hub. It's going to give us a JSON message, and we can parse that to do whatever we want with it. This one we're going to only look at virtual machines, and it's going to let us know that we've started a deallocate action on this virtual machine.
Okay, so is that plugged in directly from the Event Hub? Is that?
So that's going from the activity log, Azure activity log, going through to Event Hub, which is then coming into a queue that the Azure functions are triggered from. So we go back to our integrate. So we're going to pull from this Event Hub, which is Event Hubs are a bit fun to deal with at the moment because it's halfway between Event Hub and Service Bus, and it gets a little bit confusing. Not that one, but right. So, bit of a gotcha with Event Hubs. Who remembers this portal?
Yeah, it is a 400, right? So we're allowed to go and show these things now. Yeah, I remember this portal.
Yeah, so Event Hubs are still back here. Migration is ongoing as far as moving from Event Hubs to Service Bus. That's Service Bus. There we go. Here's our inside operational logs. So we can see, yeah, so it's all coming through Event Hubs, connection strings here. There's a bunch of doco that is rapidly being updated as this changes on how to hook up the Azure functions to the activity log. But yeah, this connection string here can be a little bit hard to find, so that's a gotcha for you. But whenever it talks about the connection string, that's the one it's talking about. Cool.
Right. So that shows us through sorry, were you going to go to something else? Right, so what I want to do next here, so to complete that picture, so now we've got our glue and all that sort of stuff. I just want to bring it back a bit and apologise. We sort of went over this a little bit because I wasn't sure on time, but I think we have got some time now, which is good. I actually want you to do some live development. If that's okay.
Awesome, great.
So again, remember we did say that you could do the, from the Azure function side of things, you could be doing the development quite quickly and publish it. So I didn't like the way that the bot was writing things out in the Slack channel.
Yeah.
So is it possible for you to update that?
Yeah, sure.
We didn't rehearse this, by the way. This is totally me. I said I'd be doing something where he has to code, so let's see how easy it is, right? Make it really easy.
So...
And this way we can also show you the fact that we're updating it again in GitHub, doing the changes, actually doing what should be a proper pull request, pushing it, and then live seeing those changes actually occur. Yeah.
So let's change this message. And let's make sure.
This is really mean to do so to someone, by the way, live, but challenge accepted.
Nope. Not sure what I've used. Let's go.
Great. Now forever when you do development, you know you're going to delete. Yeah. Okay. I'm going to have constant alerts on my phone. Thanks.
Not that one. So we've made that small update. We will.
Great. Again. I see what you're doing here.
This is called Revenge Pete.
Is that Revenge Pete? Okay.
I'm going to push that up to GitHub. So let's make a pull request. I need code review.
Yeah.
It's all right, I'm an admin. I will skip code review.
Yeah, so don't do that either. Someone raises a pull request, you really should have someone else outside of yourself review that code. In this instance, Chris is purposely just doing this so that I get message for the next 75 years of doing this. And,
So that's completely in GitHub. That's all standard GitHub, nothing we had to build there. And pull request merged and closed. If we jump back into our dashboard,
you should be able to see that as well.
you should see this one. So we've merged that into our master branch, so it's going to go straight to prod. And that is building, and we'll deploy that.
And to be fair, yeah, the Visual Studio and this sort of integration is crazy good. I have to admit it from the IDE perspective, it's quite a lot of fun to develop in there as well. So that is actually how quick and fast those changes are supposed to be. You should be peer reviewing. We should also have a test piece there. So there's probably a whole other session on how to do testing properly for Azure Functions. But once this build happens, we should be able to see that, yep, push through. Get my phone out.
Although all of our webhooks are still hooked up to the dev branch, so none of that's actually going to work. But we can see that the code has been pushed straight out into our function app here.
Yep.
So another thing, once you're using the integration with Git repo, it locks you out from actually editing stuff in here. So it gives you all that control that lets you prevent people from breaking stuff at 2 a.m. in the morning when they get too many alerts on their phone.
Thanks. Cool. That's it, pulling together. All right. So we did come in early on time, which is good. I give everyone a little bit of time back. So I'll switch back to this quickly. And we'll go into question time. I think we need to mention some of these things. So if I get this wrong, let me know. Yeah, cool. So obviously the learning path, I think everyone mentions this in most of their presentations. Please take a look at this. Actually, whilst we're talking about that and the actual learning path, the stuff that we have put together so is that you can go through and actually have a look at all the different kind of things that Chris has pulled together in those repositories. We will be not so much even open source. We'll put them up online so everyone can look at it. If you are interested in doing it straight away, because you do want to start playing with the same sort of integrations, come and see us, and we'll make sure you get that access. We just have to desensitize some of the fact that we left some of the passwords and other bits and pieces in there. So, yep, I think a lot of people have been saying there in talks as well. And education-wise as well, Vibrato actually runs like a wingman program where we help coach you through doing this sort of stuff in your own organizations, as opposed to just coming in and getting someone to do it for you. Let's not forget Spark as well. Cool. So the After Dark drone part, so please, what we're basically asking is making sure you actually do your evaluations ASAP. So that'd be really cool. And I think it's over to question times as well. Don't forget you can catch either Chris and I on Twitter. So are there any questions? Yep, go.
Is there a maximum execution time or any other limits for Azure functions?
Let's just go to the documentation and we'll come back with you in a second.
Any other questions?
Answer that one. The limit, there's no specific limit on how much time it is. It's really around how much RAM you use and things like that. What the limits are.
You're charged gigabyte seconds for RAM. So per gigabyte per second that you're running.
And that's actually a really good point as well. Again, back to the point we were saying around the whole why functions. So that's not going to happen all so often, right? So once we start getting things getting more like, more and more sort of automated, those sorts of alerts, we're talking about those functions running, potentially maybe 100 times in a day. If you figure out what that actually is, the cost of running a VM the whole time with your tools folder, when you've got those things like either croned or scheduled, it's a lot of money to just have an actual like tool service kind of running. Bringing that back down to being like, kind of 100 events a day, it's nothing. Like the cost is negligible.
Yeah. And what you can do also, if you're worried about things running away and chewing up all your account dollars, you can put a limit on how many gigabyte seconds a day you use and things like that, and it'll just stop executing functions once you hit those limits. So you've got those safety nets there. There's also there's the two separate modes that you can provision function apps in. You've got the
I was going to say if you can browse it as well, but basically got the ability to all you can eat, keep going, absolutely all of them, and just take up all the servers that run behind the scenes. Or alternatively, you can actually say no, almost like you would with sort of like marketing campaigns. What's the actual official title? I can't remember what it is. Yeah, switch across. You're on 8.
Yeah. So when you're setting up your function here, you can choose your hosting plan. So you've got your consumption plan, which is as you execute, it'll just scale it up. You've also got your app service plan, which lets you tie it into an existing app service that you may have already provisioned that's a dedicated sort of limited block of capacity.
Yep.
So you don't get that bill shock.
Any other questions? No? Cool.
The inspec stuff.
Ooh.
Can you just run that over existing cookbooks?
Yeah, absolutely.
You don't need to create a different specification for inspec.
So inspect is looking at the
Actual servers
the
themselves.
actual state.
Yeah.
So
Do you have to create a definition for inspec, or do you just take your existing chef cookbooks and run that via inspec?
Yeah, so there's a security cookbook. So there's a little bit. It's a little bit of a two-sided sort of answer. So there's a security cookbook that you can run that actually does all the inspec and does that in terms of like passing over the different recipes and stuff that are there. Alternatively, the default ones that we were looking at before were and I'll make sure I've got the question right. The default ones that were there before, we're pulling it down from basically the supermarket. Those are things like, is it PCI DSS? Is it Nginx? It's got all those sorts of things, yeah. So they're actually they run against the running state of a system. So it's actually not looking at the cookbooks. But if you use the actual server cookbook that's there, the security cookbook that comes with the inspec sort of add-ons in it, it will actually review your cookbook so that you can use it in like Test Kitchen. So when you do spin up, you can actually say, I'm not even spinning up the node, I purely just want to run through this and brief and say, if I were to go deploy this, am I compliant? So you can do that as well. It just depends on the different states that you want to run it at and where you want to run it. The place that we actually see it used more, funnily enough, is not so much even on inception, on creation. I don't know about you guys, but we've got clients out there, they've got thousands of machines already running. 4,000 or 5,000 machines. And really, inspect for them is, I want to know, am I actually compliant even now? Like, sure, we're going to do some migration, going to be recreating this stuff, but no, that's like a 3-year plan. How do I know what's out there right now? So the inspect is really good about just putting in there, letting it actually go and hit all those things, and very quickly coming back with all those alerts to say that broken. So you've got an opportunity to go and clean it up. That's where its biggest power is. And then once you actually get it into the CI/CD sort of patterns, like into that continuous kind of deployment pattern, you put the inspect stuff in part of your actual entire end-to-end sort of run, right? So it will go through and not just say, hey, like we say DevSecOps, where you do security components, go through, do the build, run the tests, actually make sure that the security tests are also run, make sure the compliance tests are all run, that's actually inspec. And then when you've got your baked kind of item component, what do you want to say, like the instance at the end, right? That can go out quite safely, and you don't have to do the auditing afterwards, in that sense. Like it's the typical things that they came up with when they looked at DevSecOps as well. So that's more so where we've been using it and where we see it used out there in the industry.
Yeah, gets tied in a lot with in the sort of image building pipeline with spinning up a Vagrant box. So you spin up a Vagrant box, run all your chef code on it, inspect runs through, and you haven't only tested what you've coded, you've also tested what's come out of the box with the OS and what's on the base of the image and stuff.
Yeah. Especially if you are actually getting things from, like from the supermarket and stuff like that, is that when you start pulling these things in, they're not always written by you. And so often you just rely on a community-driven one, especially in the open source space. So having something like inspect saying, you know what, I don't care if it's written by someone else, but I'll make sure at the end that we check that none of this is actually the case, makes life a lot easier. You can spend less time going, I'm going to have to go and rewrite every single cookbook so that I know that I've done things properly. Doesn't have to be the case. Cool. Like I said as well, just on that then, are there any more questions? No. Okay, so if you are interested, like I said, please do go check out, it's not just a typical spill, the chef guys are out there. So if there is some interest in the inspect stuff, if there's some interest in compliance, like I said, we're actually going to do a little bit more about the automation and the centric sort of server for inspect running all the time with the chef guys tomorrow afternoon. So come and check that out as well. Thank you so much for your time.